Hello, and welcome to Zane Facts Channel. If you're a fan of mind-boggling scientific phenomena and out-of-this-world facts, then you've tuned in to the right place. Today we dive deep into an event that has the potential to captivate and shake our planet like never before, the geomagnetic storm expected to impact Earth in August 2024. What does this mean for us? How might it affect our daily lives and our planet as a whole? Let's explore the fascinating world of geomagnetic storms together. The solar tsunami, a glimpse into the origins. To understand what a geomagnetic storm is, we first need to take a closer look at its source, our very own sun. In early August 2024, scientists observed a series of intense solar flares and coronal mass ejections, or CMEs, from multiple sunspot regions, particularly AR3777 and AR3780. These regions exhibited high magnetic complexity, leading to the release of powerful X-class solar flares, the largest of which occurred on August 8, 2024, sending shockwaves throughout the solar system. Solar flares and CMEs are massive bursts of solar wind and magnetic fields rising above the solar corona or being released into space. When these solar phenomena interact with Earth's magnetosphere, they can lead to geomagnetic storms, which in extreme cases can have significant impacts on technology and the environment. Interesting fact. Did you know that the energy released by a typical solar flare is equivalent to millions of nuclear bombs exploding at once? This immense energy is what propels charged particles towards Earth, creating the conditions for a geomagnetic storm. The calm before the storm, Earth's magnetic shield at work. As these charged particles race towards Earth, they encounter our planet's magnetic field, a protective shield that deflects most of the harmful radiation from the sun. However, during a geomagnetic storm, this shield is put to the test. The intensity of the upcoming storm is predicted to be particularly high, with the potential to disturb Earth's magnetosphere and create breathtaking auroras visible much farther south than usual. The Earth's magnetic field is crucial in protecting us from solar wind, but when a geomagnetic storm is strong enough, it can compress this field, allowing energetic particles to penetrate deeper into the atmosphere. This can result in heightened ionization in the ionosphere, which is responsible for the beautiful auroras, but also for potential disruptions to satellite communications and navigation systems. Interesting fact. The auroras, also known as the northern and southern lights, are caused by the interaction between charged solar particles and Earth's magnetic field. During strong geomagnetic storms, these lights can be seen as far south as the mid-latitudes, offering a dazzling display to millions of people. Impact on technology, a modern-day challenge. While the auroras are a beautiful consequence of geomagnetic storms, the potential disruptions to our modern technology are far less charming. The highly charged particles can interfere with satellite operations, GPS systems, and even power grids on Earth. During the infamous Halloween storms of 2003, a powerful geomagnetic storm caused widespread disruptions, including a complete blackout in Sweden and satellite malfunctions across the globe. As we prepare for the geomagnetic typhoon of August 2024, scientists are closely monitoring the sun's activity and the potential effects on Earth's infrastructure. Power companies and satellite operators are taking precautionary measures to mitigate any potential damage. Some forecasts suggest that this event could be one of the strongest in recent years, potentially reaching a G4 or G5 on the geomagnetic storm scale, where G5 represents extreme conditions. Interesting fact. In 1989, a geomagnetic storm caused a 9-hour blackout in Quebec, Canada. The storm induced currents in power lines that overloaded transformers, leading to widespread power outages. This event serves as a stark reminder of the potential impact of geomagnetic storms on our daily lives. Earth's atmospheric response, a dance of particles. Beyond technology, geomagnetic storms can also influence Earth's atmosphere. The influx of charged particles can heat the upper layers of the atmosphere, causing it to expand. This expansion can increase drag on low Earth orbit satellites, potentially leading to their premature re-entry. Additionally, changes in the ionosphere, a layer of Earth's atmosphere rich in ions and free electrons, can affect radio communications. High-frequency radio waves, commonly used for long-distance communication, can be absorbed or reflected unpredictably during a geomagnetic storm, leading to signal degradation or loss. This can particularly impact aviation, as aircraft rely on radio communications for navigation and contact with ground control. Interesting fact: during the Carrington event of 1859, the most powerful geomagnetic storm on record, telegraph systems across Europe and North America failed, with some operators reporting electric shocks and sparks from their equipment. The auroras from this event were so bright that they were visible in places as far south as the Caribbean. The impact on human health: a new frontier in space weather. As we explore the impacts of geomagnetic storms, it's important to consider their potential effects on human health. While Earth's atmosphere and magnetic field offer significant protection, increased radiation exposure during geomagnetic storms can pose risks, particularly for astronauts in space or passengers on high-altitude polar flights. Studies suggest that exposure to high levels of solar radiation could increase the risk of cancer and other health issues, making space weather forecasting an important tool for ensuring safety. Interestingly, some research has also linked geomagnetic storms to changes in human behavior and physiology. For example, some studies have found correlations between geomagnetic activity and increased incidence of heart attacks or disturbances in sleep patterns. While the exact mechanisms are still being studied, this area of research highlights the complex and interconnected nature of space weather and human health. Interesting fact: astronauts aboard the International Space Station are particularly vulnerable during geomagnetic storms. To protect them, space agencies like NASA monitor solar activity closely and have procedures in place to move astronauts to more shielded areas of the station during solar storms. Preparedness and future implications: navigating the storm. As we brace for the potential impact of the August 2024 geomagnetic storm, scientists, engineers, and governments around the world are working together to enhance our resilience. Improved forecasting techniques, better infrastructure design, and public awareness campaigns are all part of the effort to minimize the storm's effects on our modern society. Moreover, this event serves as a reminder of our planet's vulnerability to space weather and the importance of continued research in this field. Understanding the sun's behavior and its interactions with Earth's magnetic field is crucial for predicting and mitigating the effects of future geomagnetic storms. Space weather forecasting has become a critical component of our global infrastructure, with organizations like NOAA's Space Weather Prediction Center and NASA's Solar Dynamics Observatory at the forefront of monitoring and predicting solar activity. Interesting fact: NASA's Solar and Heliospheric Observatory and the Solar Dynamics Observatory are two key missions that continuously monitor the sun's activity, providing real-time data that helps scientists predict solar flares and geomagnetic storms. These missions have been crucial in advancing our understanding of space weather and improving our ability to forecast potentially disruptive events. Conclusion: the beauty and power of space weather. In conclusion, the geomagnetic storm expected in August 2024 is a powerful reminder of the dynamic relationship between our planet and the sun. While the potential disruptions to our technology and infrastructure are concerning, the event also offers a unique opportunity to witness the awe-inspiring beauty of the auroras and to deepen our understanding of space weather. As we look to the future, it's clear that space weather will continue to play a significant role in our lives. Whether it's protecting our technology, safeguarding human health, or simply marveling at the beauty of the night sky, the study of geomagnetic storms and other space weather phenomena remains an essential and fascinating field of research. Thank you for joining us on this fascinating journey into the heart of a geomagnetic storm. If you enjoyed this video and want to learn more about the wonders of our universe, be sure to hit the like button, subscribe to Zane Facts channel, and click the notification bell so you never miss an update. Stay curious, and until next time, keep exploring the mysteries of the cosmos.